Okay, so our next speaker going to be Nakai, and he's going to speak on this retrieval-augmented generation immediate training data leakage with strong large language model. So it's over to you. This is start when you are ready.
Thank you for your introduction. Hello, I'm Tsunato Nakai, or Mrs. Electric. Today I would like to talk about the privacy issues of Retrieval-Augmented generation. The title of this presentation is that does Retrieval-Augmented generation mitigate training data leakage risks in large language models? This slide shows the overview of this presentation. We focus on RAG. RAG is a technique that enhances the training data efficiency, knowledge updating, and reliability of large language model by retrieving relevant knowledge from external knowledge databases that are called retrieval databases. In RAG system, there are two information leakage related to the retrieval database and information leakage related to the training data. The previous work revealed that RAG mitigates the risk of information leakage related to training data. That is a good effectiveness for mitigation against training data leakage, but it has not been evaluated by using membership inference attack. Membership inference attacks are regarded as privacy evaluation tool for trained model. So our main contribution is that we evaluated the effectiveness of RAG in reducing the risk of training data leakage by using membership inference attack. And so we show, contrary to the previous work, the risk of training data leakage is not mitigated by RAG in membership inference attacks. This is the overview of this presentation. Firstly, I explained the background about RAG. Next, I will explain the research question. That is, does RAG mitigate training data leakage risk in large language models? Next, I explain evaluation, construction of the RAG system and evaluation through membership inference attack. Next, I will explain the experiment and discussion about mitigation measures and research ethics. Finally, I summarize this presentation. First, what is RAG? RAG is a technique aimed at improving the efficiency of training, updating knowledge, and enhancing reliability by utilizing the information obtained from the retrieval database during the inference of large language models. The large language model generates responses based on the knowledge they have trained and retrieved data. To apply that to domain-specific tasks, not only the construct of retrieval database is necessary, but also additional training, fine-tuning of the model, large language model is required. Previous work has discussed security and privacy of RAG system. Though Elo demonstrated that attacker can manipulate the responses by injecting malicious data into the retrieval database. Also, Elo efficiently extracted the data from the retrieval database by inputting malicious queries. Also, Jen conducted the attack evaluation on two privacy information leakage risks associated with RAG system. information leakage related to the retrieval database and information leakage related to the training data. Next, I show a research question. In previous work, membership inference attack evaluation reported regarded as information leakage related to the data in retrieval database. But there has been no reports of membership inference attack evaluation regarding information leakage related to training data. In the proposal track by them, this RAG, it is reported that RAG mitigates the risk of information leakage related to training data. However, that has not been confirmed by membership inference attack. So our research question is that in membership inference attack evaluation, does RAG mitigate the risk of data leakage from large language model? Next, I will explain the evaluation. In construct of the RAG system, we assume that the large language model will be fine-tuned for application to the domain-specific task. The risk of information leakage related to training data may differ between the response of large language model alone and those of the RAG system. Actually, previous work reported RAG mitigate the risk of training data leakage. In evaluation of membership inference attack, we conduct the evaluation of training data leakage based on the ratio of samples correctly classified as belonging to the training data set among the samples selected from the training data set and the evaluation data set. Previous work used membership inference attack based on likelihood ratio test to evaluate fine-tuned LLMs. This slide shows an example of our constructed RAG system. For example, the query is what caused drug allergy. The function LLM generates the response for tasks in the medical domain like this. In that, by referring the medical specialized database through RAG, the responses are highly specialized. So the response include many technical terms like this. As a privacy evaluation metric, we use membership inference attack based on likelihood ratio test. This attack compared the likelihood of a target sample to determine whether the target sample was used for fine-tuning or not. The higher likelihood ratio, the more it indicated that training data information is leaking from RAG system. Next, I will explain the experiments. This is an experimental setup. We use 3 large language models, Llama 2 billion, Gemma 7 billion, and Mistral 7 billion. Also, I use 3 embedded models like this, and I used 2 training data sets, healthcare and Enroll email. Corresponding to the 2 training data sets, we used 2 retrieval data sets with dog patient information for healthcare magic and W3C email for Enroll email data set. This slide shows the result of information membership inference attack regarding information leakage risk in training data across three data sets, large language model and 2 data sets. The vertical axis is membership inference attack record. The horizontal axis is each large language model and 2 data sets. When large language model is changed, membership inference attack record, MIA record, does not significantly change with or without VAG. Also, training data set is changed. MIA record does not significantly differ with or without VAG. Also, I show the experimental result of membership inference attack across embedding models. So the vertical axis is MIA code, the horizontal axis is embedding model, 3 embedding models, each 3 embedding models. So when the embedding model is changed, MIA code does not significantly change with the type of embedding model. So to summarize experimental result, we investigated the information leakage risk related to training data, focusing on changes by large language model, training data set, and embedding models. In contrast to previous work, there is no detection effect on the risk of training data leakage because of lag in the membership inference attack. So the reduction effect is limited to the previous work. Next, I discuss limitation of mitigation measures and research ethics. As the limitations, as limitation, the evaluation of membership inference attack is related to information leakage from retrieval database is not addressed in this work. So there is a previous work on this, and in previous work, improvement to membership inference attack or lag made through prompt engineering. This work used membership inference attack without the improvement. So it means we try simple test by using simple membership inference attack. As a mitigation, one of the mitigations is imposing instruction on prompt in VAG like this, but that often does not work well. Another mitigation is incorporating some modification into the query for large language model, but for example, applying difference privacy to the VAG system. As a research ethics, we used public available data set and have not collected any confidential or personal data in this work. The aim of this work is to contribute to the safe utilization and promotion of large language model by researching issues such as training data leakage. So I will conclude this presentation. This work is a past evaluation of training data leakage of large language model in large system. We conducted the MIA evaluation on large system using 3 large language models with 7 billion parameters and 2 data sets. In MIA evaluation, we clarified that risk of training data leakage for large language model is not mitigated by RAG. unlike previous one, this indicates that the reduction effect of lag is limited to previous attacks. So that's all I would like to say. So thank you for your attention.
Thank you for the presentation. Just open the floor for questions.
Thank you for the presentation. I have a question regarding the likelihood test. I'm not sure how to call it again. So there you have this equation with the two probabilities. So where do these numbers come from and what do they express?
Thank you for your question. Your question in the number.
Yes, so these probabilities from the outputs of the rack system and the reference model, what does these numbers express, or what is the probability they're expressing? Because like the output of the rack system is a text answer, right?
Okay. The number is based on the ratio of the member or non-member, right? So we make a query based on the member or non-member, and we get a response. And we analyze the response about the sensitivity of large system. So we classify the member or non-member against the response.
Okay. Maybe I can, but let's do that. Thank you.
So to estimate those probabilities, do you repeatedly send those queries? So otherwise, how are you going to estimate the probability? Quantify the output for those queries. So I assume you repeatedly do it, and then based on that estimate those probabilities. Any other questions?
Thank you for the presentation. This is a bit of a more technical question. Which membership inference attack did you use for your research, and how does it differ from the previous ones?
This inference attack is based on the likelihood based test. So it's called Leakage.
Yeah. And compared to previous attacks, which
No, that's only attacks. We tried only.
I meant like what did the previous paper use?
Previous paper is not membership inference attack. It used the prompt engineering to extract the data set from the training data set.
And did you look at RMIA?
I'm sure.
RMIA. I believe it's another one that's pretty common for large language models.
I think so.
Do you have any plans to look at that as well? Or any preliminary results potentially?
Yes. I should try some of the other tasks. But for now, I didn't try.
This makes sense. They are state of the art as well anyway. But that's all I have. Thank you.
Any other questions? Okay, let's thanks for the speaker.